Hello everyone, we are Group 5, the Mouse Security Robot Group, and here is our first video, our first deliverable, and our first week of work. So let's start with these obligatory tasks. They are all done. First, we bought the components locally, the ones that we decided to buy locally. These ones were the buzzer, the compass module, the encoders, and the motor modules. And we also did some research on the buzzer and read some documentation. We wrote a test code for it, but when we were configuring the sound of the buzzer, we found a problem. The sound was too low. So we decided to buy a siren to replace it. So we bought a siren of 12 volts, and this one is really, really, really loud, the way that we wanted. So we made some tests. It's working great. We also did some tests with the Bellator. Here are all the measures that we took. Also, we test the motors. They are both working. We put a multimeter in series with the motor and the battery and held the wheels to discover the maximum current of both motors, and we found out that the left motor has a maximum current of 10.28 amperes and the right one 6.8 amperes. And with this information, we bought the motor module. And we also installed a non-slip tape on the Bellator's wheels. How did we do that? We bought a non-slip mat, we cut it and we put it in the wheels. So this is what the wheels look like today with the non-slip mat on it. And it worked really, really, really great. The Bellator is not slipping at all. And the time we took to do these tasks was approximately the time that we stipulated. We didn't need to use the margin of error time.
Hello, professors. I am Anderson, and I will be presenting the status of my tasks individually for this deliverable. So the two main tasks that are tasks we have advanced from other deliverables are ESP32 internet connection tests. So the tests were successful. In the sequence, you can see two images that ESP32 test of Wi-Fi connection is working. I connected my phone to it. So the other one was documentations about ESP32 and mother module. So right here we can see that the documentation is linked right here, the pinout of our ESP32 and the data sheet. And to the mother module, the same thing. I think that here we have just the data sheet, so it's very well completed. And these were the tasks that has been done, and the other the other tasks are motor module unit tests and power supply. So the power supply, the batteries, we haven't bought yet. So to do this, we must have the power supply in hands. The documentation is just a simple thing. We can do this until the class of Thursday, and the motor module tests, unit tests, is pretending to be done until the class of Thursday. So this is about the tasks. So right now I'll be presenting our GitHub where we will be uploading all of our codes, test codes, and the real deploy code. So the data sheets will be here as well, and we pretend to document this very well during the semester. And just as an example, right here we have the test code of the Compass module that has been done by another team member. So the tests with the ESP32 were done in the VS Code with the Expressive extension that facilitates the programming and the configuration phase of the ESP32. Right here, we have also an example using C++ that can blinks and a LED of the ESP32, and right here the code of the Wi-Fi tests. All these code are examples distributed by the Espressif. And getting back to the homepage of our repository, so, and in this other folder, we have the datasheets of the components. We pretend to upload all of the datasheets of the components we will be using in the project. So this is all is this is in initial phase yet.
So, these are the tasks that we have to do in the first week. For the obligatory tasks, we have the documentation and the specification of Raspberry Pi 3B. So here we have the datasheet of the Raspberry Pi. So we use this to study the documentation. Here we have the documentation in the specification of encoders. Here we have the sites that we study these coders. And here we have the datasheet of the encoder. Here for the encoder, we also write a test code. Here we have the site of where we have the test code that we use. And here we have a photo of the encoder working. Here we have the internet connection test for Raspberry Pi 3B. And this task we don't finalize yet because we forgot the password of the Raspbian. So we have to format the Raspbian now. And after this, we have to complete this task. Here we have the encoder's placement determination in the robot structure. This task we don't finalize yet because we don't know yet where we are putting the encoder. So this task we have to finalize this. From these tasks, we have I spent 3.5 hours, and the expect time is 6.1. So because we have two tasks to finalize yet, this value are increased. The time spent are increased yet. And here for tasks of optional if member drops out of for the project, we have the servo motor documentation and specification, where we have the datasheet from the servo motor. Here we have the servo motor write test code, where we testing the functionality of servo motor. And here we have a video that shows the servo motor working. So for these two tasks, I spent 0.7 hours, and the time that we expect to spend in these tasks are 1.6 hours. So these tasks are finalized in this time.
For this week components case design task, we decided to use Tinkercad 3D to model it. For this design, we decided to make a plate made of MDF to put it on top of the belator, so that we can have a larger and irregular area to work with. This plate will be connected to belator using its own threaded bars. So we put the threaded bars through these holes to secure it. On top of the plate, we're going to put the component case, that is this box. Inside it, we're going to install all the electronic parts, like the ASP, the Raspberry, the compass module, and the power bank. To connect everything, we're going to put a hole to the case and the plate, where all the wires will go through. For the other tasks, like the compass module documentation and specification sheets, and the write test code, all the documentation and code are going to be found in the GitHub link that will be later available. Overall, the total estimated time was close to the actual time spent, but a couple tasks like the write test code took less time than expected, and others, like the component case design, took more time than expected.
The tasks for this week were overall the mechanical design, camera support structure design that defined overall position blotter, the motor module placement determination. They all match to one product. The disposition, you can see the ASP, the raspberry, even though they are blocks, it helps us visualize what will happen to the project. The camera case design, the case will be on the upper side of the buzzer. The camera will be held of a case, and below it there will be a disc that is controlled by the servo motor. Other placements, like the battery and the motor modules, are below the case of the plotter. The time spent was less than expected. Most of the tasks for this delivery are already done or in progress. The ones in progress are still not started. It's because we need to talk to the professors to give us help on them. The timing was just as estimated, a little bit less or a little bit more, but on the margin. So thank you.